So now understanding limit. Limit is the mathematical concept which based on the idea of closeness used primarily to assign values to certain functions at a point where no values are defined in such a way to be consistent with nearby values. If f of x is a function of x and c, L are the real numbers, then L is the limit of a function f of x as approaches to c. For example, f of x is equals to x square plus 2 is a function putting x here is equal to 2. The ultimate value we get is 6. While on the other hand, a limit is defined where x is approaches to 2. The value we get is approximately equals to 6 instead of being actual 6. You can see x is approaching to 2 from the negative side, the value of y approaching towards 6, and x is approaching from positive side, the value of function is approaching towards 6 as well. You can clearly understand by a solution table. If x is approached to 1, the value of y approaches to 3. If x is approaches to 1.5, the value of y will be 4.25, and so on. The value of x approaches to 2 where the value of y is approaching 6, 0.004, but not exact 6 is coming, you can see. Now we will consider a simple example of undefined limits. Let's look quite simple following right hand limit. Letting x approaches 0 from the right, and we consider quite simply 1 over x. In this case, when we have 1 over x, as x approaches to 0, x would be slightly bigger than 0. Here plus sign at the 0 point, it is a quantity shrinking to 0 is always positive. The question is, what will this give us? Let's take a very simple numerical sequence for x shrinking to the 0 from the positive side. We could have x equals to 0.1. Then x is even smaller, x gets smaller and smaller, always positive. As the x is shrinking to 0 over positive side, what happens to 1 over x? So in this case, the 1 upon 0.1 will be 10, the 1 over 0.01 will be 100, and so on. You can see this is going as x is getting smaller and smaller by always positive. So 1 over x is getting larger enough, so the x is shrinking to 0 to the positive side, and 1 upon x blows up to the infinity. So this limit does not exist, it is undefined, but very specifically by blowing up to the positive infinity. So we simply write the limit is equal to the positive infinity, that is writing here. What if we look now at the limit of 1 over x as x approaches 0 from the left hand side? What would change? But this approach 0 from the left side slightly less than 0, therefore negative. So you can see the x goes to 0 from positive side, the 1 over x gets larger and larger, but always be negative. You can see the values of x and 1 over x in the solution table, which is negative. So what we get, the limit is undefined but up to negative infinity. You can see 1 over x positive 0 yields positive infinity, as 1 over positive always gives positive. So 1 over positive 0 shrinks to case of 1 over negative 0 case. Same argument, but the limit goes up to the negative infinity. So what about the two-sided limits? Limits from right and limits from left. What if we ask what is the limit of as x approaches to 0? In this case, it is not specified that 0 is approaching from the right or from the left. We can say in this limit is undefined. There is a graph of 1 over x for positive real values and there is a graph for negative values. As we approaches to 0 from the right, positive y infinity, as we approach 0 from the negative side of the infinity.